Here's a question nobody ever thinks to ask. What does it feel like? Standing right next to it. Everyone who's been there says the same. You feel small. And then you find out it almost destroyed the company that created it. And somehow that makes the whole story even more fascinating. This is the Airbus A380, a machine that rewrote what we thought was physically possible and paid a brutal price for it. Let's start with the numbers, because they deserve a moment. Maximum takeoff weight, 575 metric tons, the equivalent of 40 fully grown African elephants on a single scale. The wingspan is nearly 80 meters. Lay it alongside a football field and the wings reach from one goal to the other, every time, end to end. The tail stands 24 meters, the height of an 8-story building. Think about that the next time you're boarding. And here's what separates it from every other big plane. The Boeing 747 has an upper deck, but only at the front section. The A380 runs 2 full floors from nose to tail. Nose to tail, every inch. It's not a jumbo jet with a loft, it's a flying multi-story building. In maximum one-class layout, the A380 carries 853 passengers, the all-time record in commercial aviation. That number has never been matched by any airliner before or since. Most airlines configure 3 or 4 cabins, fitting between 450 and 600 people. But engineering toward that 853-person ceiling required rethinking the entire aircraft from scratch. Every time you add a seat, you recalculate the floor load, reposition emergency exits, redesign oxygen systems, air conditioning, galleys, hold space. All of it. Every single time. Getting to 853 wasn't a logistical challenge. It was a fundamental structural rethink of what a passenger aircraft can be. Now, where do you take 600 people when you have a plane this size? Somewhere far. The A380 has a range of up to 15,000 kilometers on a single tank. Singapore to Los Angeles, Dubai to New York, without once touching the ground. That's more than 17 hours of continuous flight on a single tank of fuel. It cruises at 900 kilometers per hour at altitudes between 12 and 13 kilometers, where the air is thin, drag is low, and the physics of flight works in your favor. Here's the counterintuitive part. The longer the route, the more efficient the A380 becomes. Takeoff burns an enormous amount of fuel. Once you're cruising, the math changes completely. Once the A380 is cruising, its enormous wing generates extraordinary lift relative to fuel burned per seat, which is why it was built specifically for ultra-long intercontinental routes. Speaking of fuel, the numbers are staggering. The A380 carries roughly 320,000 liters of jet kerosene on every single flight. That fuel alone weighs around 250 tons, nearly half the aircraft's operating empty weight. Onboard computers redistribute it continuously throughout the flight to keep the center of gravity precise. A full refueling cycle takes up to 3 hours and can cost over $200,000 at current kerosene prices for a single flight. But divide that across 500 passengers flying 15,000 kilometers, and the per-seat fuel cost becomes surprisingly competitive, even against aircraft a fraction of its size. While we're talking about the wings, there's something worth watching if you ever fly on one of these. Find a window seat and watch the wingtips. In turbulence, those wingtips can flex upward by 4 full meters. First-time passengers who notice it have been known to panic. They don't need to. That flex is completely intentional. A rigid wing concentrates every gust load at the root, accelerating metal fatigue over time. A flexible wing distributes that force along its entire length. It's not weakness, it's physics. During certification, Airbus engineers loaded the wings to 150% of their maximum design limit. Then they kept going. The tips bent past 7 meters before the structure finally failed. In normal commercial service, the aircraft never comes anywhere close to those values. What looks alarming from the window seat is actually the system working exactly as designed. That is the whole engineering point. The A380's size created problems the moment it touched the ground. A double-deck aircraft needs jet bridges that dock at 2 levels simultaneously, which almost no airport had. Its wingspan demanded wider taxiways and larger apron areas. When the jet entered service, airports across Europe, Asia, and the Gulf began major infrastructure rebuilds. Some airports spent hundreds of millions on upgrades. Even then, only around 130 to 150 airports worldwide can handle A380 operations without restrictions. That's not many. And that became one of the core reasons the A380 struggled commercially. You can only fly to places that are physically ready for you. Building a single A380 takes approximately 3 years, from the very first component to customer delivery. 3 years for one aircraft. 4 million individual parts. Around 1,500 suppliers worldwide. Wings from Wales, fuselage sections from Germany and France, the tail assembly from Spain. Then everything travels by sea and specially designed road convoys to Toulouse, where final integration takes months, handled by thousands of engineers and technicians. It's one of the most complex civilian manufacturing operations in history. Full stop. And then comes the test that every aircraft in the world must pass. Every commercial aircraft must evacuate all occupants in under 90 seconds, using only half of its emergency exits. For the A380, that meant evacuating 853 people. Airbus ran the certification test in 2006. 853 volunteers, a dimmed cabin, multiple exits deliberately blocked. Real conditions. No rehearsal allowed in the final hour. The aircraft was empty in 78 seconds. The world's largest passenger plane met the same safety standard as any 50-seat regional turboprop flying today. And here's the quiet surprise. Despite 4 engines and 575 tons, the A380 is genuinely one of the most peaceful aircraft to fly on. Airbus invested heavily in wing aerodynamics and engine nacelle design, specifically to reduce the aircraft's noise footprint at takeoff and landing. Airports in London, Dubai, and Sydney recorded measurable drops in noise complaints from surrounding neighborhoods after A380 services began. Not what anyone expected. Which brings us to the part that still stings. The development program began with a budget of approximately 11 billion euros. By the mid-2000s, an incompatibility in the electrical wiring harnesses between the French and German production lines caused delays that cascaded across the entire program. Different software versions in different countries. That was the root cause. Total program costs eventually surpassed 18 billion euros. Airlines restructured their orders. Early customers began pulling back. Delivery delays ran into years, not months. The program was unraveling. In the end, Airbus delivered 251 aircraft against projections that required between 420 and 750 sales just to reach financial break-even. The A380 never reached that number. The program was formally closed without recovering its investment. The most expensive product development lesson in aviation history. Engineering brilliance and commercial success turned out to be two very different things. The A380 proved that beyond any doubt. It remains an engineering achievement without parallel in commercial aviation. If this changed how you see the world, you know what to do. Thanks for watching, stay curious, and I'll see you in the next one.